Hello everybody, like I promised in class today, I'm making two videos. This is one of them. So one video, each of the video will have I'm going to upload them on Moodle. I'm going to insert quizzes into them, interactive quizzes. So one of the video will be for your assignment, the other video will be for your quiz. So quiz 1, assignment 1. Okay. So, and because I want us to cover all the materials that we are looking at in this class. Okay, so current slide. I need to add slideshow. Okay, begin. Okay. Excuse me. All right. So the objective of lesson 2 is to identify hardware components, and these components can affect your computer performance. I will explain how central processing unit, CPU. The CPU, what it means, is like the brain of a computer. Types of memory, system requirement, the purpose of software update. We will look at arithmetic logic unit, byte, cache, central processing unit, circuit board, clock speed, control units, execution cycle, gigahertz. What all these things means is what we're looking at. And more, we'll look at what? Motherboard, multi-core processor, multi-processing, multi-threading, non-volatile memory, read-only memory, registers, system unit, trashing, volatile memory. What does each of them means? Okay, so now, how efficiently hardware and software complete task is called performance. So we rate computer performance on how, or software performance on how they efficiently complete a task. So the system unit is like the whole case that houses or contains your PC. So system unit is the case. Look at that, like the container, the case that contains the computer's main system components. Okay, now I'm going to show you now. The main circuit of the computer is called motherboard. The motherboard is where you place all the components. Okay, in week 2 you're going to look at a video on how to assemble a PC. So all different components that makes up your main hardware, they are fixed on a plane or a grid called motherboard. Okay, so a circuit board is a thin metal plate with an extensive electronic circuit. Okay, so all of the essential chips and the circuitry that connect them, see that? You place them on what? On motherboard. Okay, so this is how a motherboard looks like. See, all your PC. That's it. Correct? CPU. This CPU, which is a central processing unit, is like the brain of the PC. That is the most expensive part of your laptop or your PC. Look at this random board, motherboard. Now this rectangular container here is called motherboard. That is where you put all this circuitry. See, the fans is here, many other stuff here. That's it. That's your laptop. So how these are done, I don't know, but you can buy all this individually and assemble your own laptop. So the central processing unit, which is shown here, you see that CPU, is actually a single chip, and it contains all the electronic circuitry that a computer needs to process data. So this is actually the powerhouse right, of the PC. Okay, and it's called central processing unit. That is all. If your computer is going to work, all this functionality comes from CPU. Okay, and a chip is a small thin piece of silicon containing electronic circuits. So that is why chip sometimes it's called what? Integrated circuit, IC. Now the chip, the way it is done in the electronic industry is a piece of material that is made from silicon. Okay, and we call it chip. You call it chip. So now this CPU, like I said, is the brain of the PC. CPU. The CPU has some components. One of the components is what? Arithmetic logic units. So this is where all the calculations and like adding numbers, performing binary shift, every other things. That's where all those things happen. Then you have a control unit, which is a part of CPU. Okay, the control units coordinate all the processor activities, manages the flow of information through the processor. Okay, and we also have what is called registers. Okay, and the registers are like a memory cells. They are the memory cells for storing the data needed by the ALU to perform its calculations. So if you are adding 4 plus 5 to get 9, for instance, so the 4 plus 5 are temporarily stored in these registers, which is part of your CPU. Okay, before they can be added. You want to add two numbers, 4 and 5 together, they have to be held in a place called registers, which is a part of what? CPU. So the CPU, which is a central processing unit, carries out instructions by repeating 4 basic operations, which is called machine cycle. Machine cycle. So number 1, the CPU must be able to fetch instruction and decode it. Okay, retrieve number 4, that's a number, it knows the meaning of that. Retrieve number 5, that's another number. Okay, then that's fetching and decoding, accepting and understanding the meaning of the numbers. The next thing is the CPU will retrieve instruction for addition. After that, it will decoding the translation or translating the instruction into a form that computer can execute. See, like 4 plus 5 equals 9. 4, 5, retrieve, understand 4 and 5, compute addition, that is instruction, and then execute it. So you have fetching and decoding. Okay, so you have executing and storing it. Okay, look at it. Fetching and what? Decoding. That is instruction cycle, I cycle. The next one is what? Executing and storing up the execution. When you had 4 plus 5, that's execution. That's called E cycle. You have I cycle, instruction cycle, retrieving, decoding, then executing and storing. That's E cycle. That carries out the commands in the instruction, like to add for 2 numbers, for instance. Okay, and storing writes the result to memory. Okay, and it continues basically in this way. For instance, let's look at this 5 plus 25. So you enter 5 plus 25 in your application. That is instruction cycle. So the control unit fetches the application instruction and the input data from memory. That's I cycle. So it decodes, fetch, decode, execute, store, execute. Fetch, decode, execute and store. Fetch, decode, execute and store. So that is FDES. FDES. You fetch the instruction. You don't have to see all this in the memory. It's a kind of what actually takes place. Then you decode the instructions. You execute it. 5 plus 25 should give you 30. So you fetch it. So you decode what actually plus is doing, right? So 5 plus 25. So you carry out the executions here, which is going to be 30, and you store the results and display the result here. So what takes place between 1 to 4? It's done inside your CPU. So clock speed. Now, clock speed is one of the ways through which we can measure the performance of a PC. Very expensive one have higher clock speed. So machine cycles are measured in microseconds, nanoseconds, and even picoseconds. The faster the machine cycle, the faster your computer processes data. So the speed of the processor, you see that, directly influences the speed of the machine cycle. So when you are buying a PC, you have to check the clock speed. Okay, so the processor speed is also called clock speed, which is the number of instructions the CPU can process per second. Some CPU can only process fewer instructions in a second. Some can process much more in a second. So the higher the clock speed, the better your PC. So the computer has a system clock that generates irregular electronic beats to set the space, right, and timing of its system operations. So each bit of the system clock is called a cycle. It's called a cycle. So the clock speed is stated in megahertz. That's a frequency. If you have done physics before, hertz is like a frequency. If I'm able to roll my hand like 20 times in a second, that's 20 revolutions per second. So the clock speed is 1,000,000 cycles per second. For your PC, my hand, I cannot do million rotation with my hand. That's not possible. But your PC can do much more than that. Okay, and you have a gigahertz. Gigahertz is much more, a billion cycle per second. A hertz is called 1 cycle per second. Cycle of instruction. Remember the instruction here. You see, instruction cycle: fetch, decode, execute, store. 5 plus 25, you fetch it. Then you decode what 5 and 25 means. They are integers. Okay, and then you decode the meaning of addition. So inside the CPU, there's an instruction for addition, and your CPU understands that. So it's going to decode that and execute the result here and store the result, and what? Display the result. So a hertz is 1 cycle per second, and megahertz is what? 1,000,000 cycle per second, while gigahertz is called billion cycle per second. Everything is here. Now, another measure of CPU performance is a bit. Is a what? A bit. Now, a bit is either 1 or 0. 1 or 0. Okay, a bit is 1 or 0. If you check your laptop, let me just bring up a calculator here. Calculator, and then let me see scientific. No. Programmer option. Now let me see how you can convert number 65 into binary. Let me tell you what that means. In a PC, everything you see on your keyboard, computer actually represent everything using numbers. For instance, uppercase English alphabet, uppercase A, as in A. This alphabet A here, you see, is represented as number 65. Then the computer will actually store that number 65 in a binary format. So let's see what 65 actually looks like in a base 2. Base 2 means series of zeros and ones. So 65. You see, look at the bin here, binary 0 1 0 0 0. Now this makes up 8 bits. 1 is called a byte, 0 or 1, which is a base 2. It's called a byte. But to represent a character in a computer, to represent your alphabet, to represent your space bar, to represent P, L, K, all the English alphabet, all the characters on your keyboard, you need a integer code called ASCII code, okay, which is ASCII, American Standard Code for Information Interchange. Now, for uppercase A, the ASCII code is 65. The 65 is actually converted to what? These 8 bits, and then the computer will store this 8 bit. So a group of 8 bits is called a byte. You got it? A group of 8 bits is called a byte. Let me just see if I can get my... Okay, yeah. So a group of 8 bits is called a byte. So another measure of CPU performance is bits size, which is how many bytes. You see, a byte, like I've just shown you, is 8 bits. 8 bits. I'll talk more about that in class, okay? A byte is 8 bits. So to store any information, you need minimum of 8 bits, which is 1 byte. 1 byte, 1 byte is called a 1. So an 8-bit CPU can process only 1 byte at a time. 16-bit CPU can process 2 bytes. So the higher the number of bytes that the CPU can process, the higher the performance. So 64-bit CPU can process 8 bytes at once. That's a lot of work, man. It's a lot of work. Okay, now you see what is called a RAM here. A RAM. When you open an application, for instance, Microsoft Word, and you are typing. In those days, if your computer loses the power, or you have not saved that information, everything you have typed is lost. So when you are typing an application or using Microsoft Word, you are typing a letter, okay? Before saving it, what you see on the screen temporarily resides in what is called a RAM. A RAM, which is random access memory. Random access memory. Now, when you now press Ctrl S to save it, then everything goes to ROM, read only memory. Okay? So once again, 1 byte, 1 bit, 0 or 1 is not enough. You need minimum of 8 to make up 1 byte before you can represent a character. So you have now the CPU I've just shown you. That CPU, the brain of the PC, is the most expensive part of the PC, but we have different types of them. Okay, so you have multi-core processor. It's a single chip that contains more than one processor. If you are doing serious research, sometimes you might have to need that, especially if you are a big data scientist. So if a computer contains a multi-core processor, the operating system can use a multiprocessing to split tasks among the processors to do what is called, distributed processing or parallel processing. So each processor can work on different tasks. Task 1, task 2. You can have 10 different tasks and work on them at the same time. If you want to use just one CPU with one processor to perform that, you're going to spend way longer time to get the result. So multi-core processor work faster than just one single CPU. So you have a single core processor, okay, and you also have what is called multi-threading. So multi-threading is actually a thread. A thread is a process. For instance, when you are printing, you can call that a thread. When you are printing, you are sending a job to a printer, they are trying to do something else. So the ability to be able to do all these things at once by your OS is called multi-threading. Multi-threading. So, okay, I've seen that. Sorry. Now, like I said earlier on, processors are of different types. Okay, you have a single one. You can have processors working at the same time. And in terms of memory, in the class, a computer accepts the inputs, process the inputs, and output the result. Inputs, process, and output. So when you input, for instance, that 5 plus 25 is going to stay somewhere. You must have a location to hold your data. That is called memory. So the CPU, the operating system, and application uses memory. Memory is like a chips inside the system unit to store your data and instruction. Okay, most of the time you actually store data and instructions. So a computer has two types of memory: volatile memory, which is temporary memory, and non-volatile. So your RAM is the one that is directly connected to your CPU. So when you are typing, temporarily, like 5 plus 5 is staying in your RAM. But when you save it, Ctrl S, whatever, it goes to your ROM. Okay? But RAM, it's very, very important. It is the one that is directly connected to your CPU. The memory that is directly connected to your CPU and is very fast. But if you don't save it and your power is lost, whatever is in your RAM is lost. That is why it's called volatile memory. But when you save it, it goes to what? ROM, read-only memory, which is a non-volatile because it stores information permanently. It does not lose its content when you turn your power off. But for the RAM, when you turn your power off, it loses the content. So RAM is volatile and it's temporary. And the meaning of RAM is what? Random access memory. ROM is non-volatile, is permanent. And the meaning of ROM is what? Read-only memory. Like your flash drive, there's a ROM part in your storage unit. Your compact disk, you can see them as ROM because you can store information there permanently. So once again, RAM, data, information, and instructions from applications and the OS are stored temporarily in RAM. You can see a RAM here. That's how a RAM chip look like. Okay, if your laptop is not performing well, you might have to replace the RAM. You have to replace the RAM. It depends. So the RAM usually consists of several chips on a circuit board called memory module. Look at that, which is plugged into the motherboard. The whole of this rectangular space is called the motherboard. I've told you earlier on. But this part that this person is holding is called RAM chips. Okay, you can enhance it and buy more to enhance the performance of your PC. So a RAM has a significant effect on performance. Without enough RAM, the OS must move data in and out of RAM frequently. So if you don't have enough RAM, if you are running out of RAM, what you have to do is to change your RAM or add more to your RAM. Random access memory is part of your motherboard, and this is it. You see that? Okay. And the CPU moves information from between this RAM and this. This is your CPU. I mean, this is your this is your CPU. So the RAM is kind of directly connected to it. So information movement from your RAM to CPU is very fast. ROM is a bit away. So between your CPU and ROM, you have your RAM in between. So you can move information from your CPU to RAM, then to ROM. So to travel from CPU to RAM is not as far as traveling from CPU to ROM. So distance from CPU to your ROM is greater than distance from your CPU to your RAM, because the RAM is in between. Okay, so thrashing means the OS spend more time swapping data than running software. So thrashing means the operating system. Your Windows or your Mac is a big software that have been written to control. The operating system controls whatever you do on your PC, your file management, shutting down, sending works to printers. All these are not automatic. The OS does all these things for you. Okay, and when your OS is spending more time swapping data than running software, that is called thrashing. So, like I said earlier on, ROM is read-only memory. Okay, there's a read-only memory. See, as you can see it here, this is what? This is a CPU. Now, your ROM is not directly connected to. You see, there is something in between them. So, read-only memory, ROM, is stored on a single chip on a motherboard. This is a ROM chip, as you can see it here. It's a ROM chip. So the OS, which is the software, in fact, OS is actually called operating system. OS, operating system OS, is actually called master control program. Without OS, your PC cannot work. So OS comes right there when you purchase your PC. Okay, so the OS, which is operating system, retrieves data or programs from the ROM when it needed it. Okay, the OS does not write over the content of ROM. No, it doesn't do that. So ROM continues. We have what is called electronically erasable programmable read-only memory. Okay, it is normally I've said earlier on that ROM is non-volatile, but there is another type of ROM that can be programmed, that can be modified. That is called EEPROM, electrically erasable programmable read-only memory. EEPROM, electrically erasable programmable read-only memory. You have your flash memory, okay, like your flash drive. Flash memory is a type of ROM that can be updated much more quickly than EEPROM, and has largely replaced your ROM. Flash memory is now being used on mobile computers and peripheral devices, your flash drive, So you have a cache. Now, excuse me. In addition to RAM, the brain of the PC, the central processing unit, accesses memory, caches to speed processing. Now, if you are going to wipe off some apps from your mobile phone, you see what is called cache. So cache, you can wipe off what is in the cache too. It's like a memory. Okay, so level 1 cache is a small amount of memory stored on the CPU itself, apart from the registers, where it is almost instantly available. So there is a register, there is a cache. All these are what? Memory. Cache, it's good, right, to sometimes temporarily put some trash information in. So you have level 1 cache, you have level 2 cache. Level 2 cache memory is a larger amount of memory that reside on the CPU or on a chip that has a direct connection to the CPU. Okay, let's look at what a cache is. Look at this diagram. You have a CPU registers, you have a ROM, you have a virtual. Now I told you earlier on that ROM is almost directly connected to what? CPU. You see that? But RAM, sorry. And ROM is further away. So the distance from ROM to CPU is longer than the distance between RAM and CPU. So if you are moving information from CPU to RAM, it's fast. Okay, but when you press Ctrl S to save your information, it goes to ROM. So this cache level 1 cache, level 2 cache are like kind of auxiliary memory place to hold the trash information. See, temporary and volatile. Excuse me. So processors and laptops, desktops, and servers generate a lot of heat. So we need a what? Kind of heat sinks and fans to prevent overheating. So the fan moves ears across the heat sink, which collects heat from an electronic component so that the fan can cool it quickly. Okay, that is very, very important. You see the fan all the time. You also have what is called performance indicator. Okay, and performance indicators that can tell you how efficiently your computer is working by tracking the CPU usage and RAM. Now on your PC, Windows, if you press at the same time Control Alt Delete, it's going to bring up something like this. Let me try it. Control Alt Delete. You see? Now, you see what is coming up? Task Manager. You can see more details. You can see the performance of your PC. You can see it here. You can see the memory. You can see disk. These are the things that are taking place on the PC. You can see my apps memory. Every other thing that I have. These are what I have on my PC. Okay, so that's what is called performance indicator. I've just shown you now. Okay, this. So on Windows, I don't know of Mac, but on Windows you press Control Alt plus Shift. That brings up the. So you also have a system requirement. Okay, system requirement. It's very, very important. So for my PC, for instance, if I come right here, PC, my PC, this PC, and I have to delete many things here. So if I right click this and say properties, so you can see all this basic information about my PC. The RAM is 16 gigabytes. The OS is what? 64-bit operating system. And many other things that you can see. Okay. Yeah, I have to delete some file. I'm running out of memory there. Let me get to full from current slide. So you have hardware requirement. So many hardware now include features. Some applications include features designed for particular hardware. But most popular applications now include features that can accept input from touch screens, fingertip, many other stuff. Okay, and we have two types of software. We have application software and we have system software. Excuse me. Your operating system, the one that's your Mac, your Windows, or Linux, Linux. These are system software because they particularly control your hardware. It's a system software. That's then we have what is called, so we have two. We have application software and system software. So system software is like your operating system and others that control your hardware. Whereas application software, just like your Microsoft Office, like Access, PowerPoint, Excel, all those are what? Your image processing program, your 3D image app on your laptop, many other stuff, we call them application software. So it's two. Okay? System software and application software. So if you purchase an original version of the software, an update may be available, like updating your operating system, a number of times on your phone. They will ask you a new OS for the phone is available, update it. So that OS is a system software. And when you update it, it's going to make the newest features available on your phone. And software developers uses version numbers to keep track of the software they release. They might call the original one version 1.0, and an upgrade can be called 2.0, 3.0, and so on and so forth, depending on the agreed nomenclature. So installing means what? Moving a copy of the software from its distribution location to your computer. So a software might reside in California, for instance. Maybe you are trying to install Python programming language or R. So when you install it, means it is physically in a place, a remote place. If you have internet service, you can download it from that location onto your PC, and you can install from your flash drive. Okay, and you have automatic updates. They keep writing, fixing bugs, updating the software all the time. And once they have updated it, you need to download the updates. So most of the software have got a module called automatic updates. Sometimes you might do the you might update it manually. Okay, so I have to skip some of them. So in Windows, you use Windows Update to check for the latest updates to Windows and to retrieve your update settings. So Windows Update can download 3 types of updates: important, recommended, and optional. So that is what I have for you. I think okay. I think I still have some things here. So we have learned about system unit, which is the box that contains all your computer main components, including your motherboard. Now the motherboard is like something like this, and that motherboard contains all the circuitry. Now the motherboard and everything, you put them inside a case. That case is called system unit. So let's move ahead and talk about all this. Okay, that's all. This is just like a revision. Okay. All right, I think that's okay for this video. Thank you.